Welcome on, my friends. It's Tech Conversation Fridays, secrets, everything today. How are you, German?
Hello, my friend. How are you? Thank you very much for a kind invitation, my friend.
It's awesome to have you here. So, for our audience, thank you for being back. This is not Mike. Don't worry, that's not Mike. Mike is normally here with us. Mike is out this week. But I was thinking about in the last couple of months, I've seen a lot of conversation about data in the cloud. And I have worked with it, but I said, who do I know that actually is an expert that knows about data in the cloud, specifically in Azure? And I said, I have my friend Herman. So I said, I'm going to have to bring him into the show. So, Herman, where are you? Give us a little bit of a background of your experience, and then we can dive into the topic for today.
Well, thank you very much, Carlo. Well, basically, I work for Azure. I've been a cloud architect with Microsoft Azure regarding data. Data specifically is one of my core topics because Microsoft Azure, is a jungle of services, and we have a lot of solutions, but you have to kind of pick up which ones are going to be your favorite toys. And in my case, is everything related to data. And I'm talking about, for example, Azure Synapse. That's one of my favorite toys in Microsoft Azure.
So, talking about that, that's one of the reasons because, like, I saw Synapse and I understand what it is, but I'm like, I know that you have dived deep into it. Um, and that's what I think the topic for today. I started thinking about a database. We know that we store data. Are we actually using it correctly, or are we just using a trash can? Like, we're just piling every junk that we can find. And in the cloud, it's not like on premises. And I think that you and I have found customers that actually some know what to do with their data, others just use a database or some of the services as a trash can. So before we dive into some of the services, what do you think? What should be the correct use for a database or some of these services that are available on the cloud to store your data?
Yeah, well, that's a really interesting question because, for example, let's use something really simple and everybody knows. Let's say SQL. Okay, Azure SQL, for example, a lot of people are using Azure SQL as a storage more than a transactional database. And some customers even put some pictures and videos inside SQL, and that kind of thing. That is start add up the amount of data and the size of the SQL. Okay, so if you ask me, what is the right way to use your SQL, for example, in Azure SQL DB, the pass option is only for transactional purposes and only the data that you are really using. Most of the time, at least 40% is data that is just there and you are not longer using it. So most in most cases they start thinking that, what, I need to improve the performance of my SQL because it's a little bit slow, so I'm going to ramp up the power, so I'm going to go for a higher flavor. But the solution is way simpler, is to clean up your database. You could select, for example, the most recurring queries, what is the data, or what is the most critical data, the most access data. There's a lot of techniques, and then you will keep only the data that you need. And sometimes when you clean up your database, you realize that, what, I'm going to shrink my SQL because it's too big. Some kind of a rule of thumb, I would say, that to kind of understand your behavior of your SQL is in, for example, in SQL Pass in Azure, in SQL database, you go to the monitor part and you see the CPU behavior. If your CPU is always peaking at 90%, perhaps you need to increase a little bit the flavor. Okay. But if it's always at 5, 10%, that's too much. I would shrink my SQL. That's kind of a starting point to tidy up your data using SQL database.
That is gold right there, because a lot of times people oversize or undersize. I remember on premises, I had one time for one of the companies that I'm working for, the developers were, oh, the server is too slow. We need a bigger server. They had like the biggest box available in the planet. Literally at that time, it was, I think, was an 8 socket box. And I think that was 64 gigabytes of RAM. And they were complaining. So we actually end up looking at it, and their process, it was single threaded. So there was nothing that we could do. So we then actually shrunk the box. We virtualized in that same box. And like you said, we look at the monitor and we put it down, and then performance went up through the roof
Okay.
because then now they were able to run more sessions with the additional. So let let's go a little bit deeper into what you're saying. You're saying that people sometimes use a database to store files like
Correct.
pictures and videos.
Yeah.
So in the cloud, there's a lot of different options for that. Like there's blob storage, there's some type of file storage, depending on the cloud flavor. In Azure, it's Azure Files. In AWS, they have something similar. GCP has the same thing. When will you, as an architect, will advise or will say, hey, you need to look at your app and change it? Is the database becoming the bottleneck? Is the response? How do you figure that out, or look at that?
Yeah, that's a very good question because the responsible answer is it depends. Okay, could be a lot of stuff. Most of the time, is the way that they're using the data. Okay, so for example, very interesting distinction would be what's the difference between blob storage and data lake? That's a very common question because at the end of the day, between you and I, it's the same technology under the hood. Okay, but the main topic, for example, the main difference is that out of the box, in data lake you could create hierarchical order, so you could create folders inside folders inside folders. In blob storage, out of the box, you just create container. It's kind of a flat, it's flat the way that you are
Yeah.
distributing your data. Okay, so that's main difference to do to tidy up your data at the end of the day. So if you have in data lake, for example, a folder called Carlos Vargas, and inside Carlos Vargas you have project 1, project 2, project 3, it's way different than to have everything flat in blob with Carlos and project 1, project 2, project 3. So most of the time that is really really advantageous, and of course the security options are a bit different as well. Then you have, as you mentioned, Azure Files. Most of the time, Azure Files is you deploy Azure Files when you want to deploy, when you want to map a drive, when you want to work under SMB protocols. That in that kind of scenarios, I would recommend Azure Files. Okay, or you want to persist data from AKS. Most of the time, you use also Azure Files. That's the way that I would recommend to manage the storage in Azure. Now, when you have application, let's say that you have a web application in App Service, you are using database behind as a, let's say, backend. Well, we have several options as well. It could be a Cosmos DB if you are working with, let's say, JSON data, for example, could be. Or if you are using just our old friend SQL for transactional purposes, very relational formats. So that thing is going to be the perfect world if you want to really save cost and keep everything optimized. Because Azure, again, in Azure you have a lot of options, and every option is really sexy. So the right way to deploy in Microsoft Azure is first define your project and what things Azure has that could help you to deploy well your project. And not the other way around. Oh, this is really interesting. Let's put this. Oh, this is really interesting. Let's add this. No, because in that sense, if you follow that road, you're going to end up with a lot of things deployed. And not only the cost of that, also the management of that is going to be really difficult because being in the cloud is simple if you know how to manage the resources. So keep it simple, keep it straightforward, use the thing that you really need, and not because it's really sexy I'm going to add to my scenario. That would be my kind of three tips for that situation.
That's really interesting. Is the key. You need to start with the strategy. If you don't build a strategy, it's very easy to get a credit card and put it in there. And like you said, deploy this, find this tutorial, do X, do Y. But it's not until you actually sit down to look at it that then you end up with a monster. And I think that that's when we were talking about what are the different options to manage your data. It was very interesting because I know that you have been digging into Synapse, um, and I've been looking at it, and it's still over my head, but I'm like, I know that your man knows what is. So what is Synapse? How will someone use it? And I know that you have uh, something ready there is that we can start probably playing and looking at it. So what is Synapse, and why somebody should look at it?
Okay, Synapse. Why is it really important? Synapse. Why is kind of a in this moment is a kind of a hot potato in Azure because with Microsoft Azure Synapse, you are bridging the gap between structured and unstructured data. Okay, so under one solution, you could do multiple queries to JSON, to SQL, to Cosmos data, Cosmos DB data, etc. So in that sense, you could create a one-stop solution regarding your data analytics. On top of that, you could deploy everything related with the Spark world, the Apache. Okay, so you have the capabilities of Apache. And also, if you really want to go the road of, for example, machine learning, you could deploy notebooks and use Python for coding, for analyzing your data. It's really interesting the way that we are using Synapse, because with Synapse, you could create, for example, a specific SQL pools, and with that, you can persist your data with a specific schemas if required. But now, what is really getting traction is the concept of lake database, which at the end of the day, you are putting your data into a data lake, okay? Let's say one CSV, and then you query on demand the data in that data lake, which is inside that data lake. Remember that SQL, this is really interesting. Remember that SQL at the end of the day is two motors. One is the computing motor and the other one is storage. Now, Synapse kind of divided that. Synapse is only the compute power if you want, and the storage will be data lake. And that is the road of SQL serverless. And that's the thing that I would like to show my friend. So I'm going to put this here. Let me know when you can see my screen, my friend.
Perfect. We're there. I'm
Okay,
excited.
now
I'm excited.
this is a very simple demo that I'm going to show, but I want to go straight to the point. So here I have my Synapse, okay, and my blob. I'm going to work with my blob. So let's open my blob. Here I have my containers. You see, here I have some data. So I'm going to work with this guy here. Okay. Now let's go for Synapse. When you open Synapse, this is the first step. This is kind of the starting point of Synapse. This is the workspace. Here you have all the preliminary information, the configurations about your SQL pools, your Apache Spark, your Data Explorer. Okay. But here's where the magic happens inside the studio. Okay, so let's go there. We
So
click
it's
here.
not only a place where you store the data, but also give you the tools and the capabilities to actually build all that.
Well, Synapse does not store any data at this point unless you create this here, dedicated SQL pool. How this work? When you create your dedicated SQL pool, you are going to store your data like a regular SQL server, but the data is going to be stored and because in a data lake, because under the hood, Synapse has associated a data lake. When you deploy Synapse from the beginning, one of the options that you have is which one, where do you want to store your data, basically, okay? And that is going to be a data lake, okay? So that's why it's so flexible, this tool. You have several options and several ways to follow this. For example, here it is, okay? This is the data lake associated to my Synapse, okay? Now, let's go with this. This is Synapse where I'm going to do all the tricks. So what I'm going to do, I'm going to query using serverless query a data which is in my blob storage. Okay, so we have several options here for data. For example, is when you have something already created, your SQL serverless created here, which is a logical way to put data. Okay, that's why it's called serverless. You could also create pipelines. Okay, so for example, and this is they are leverage. It's a leverage of a data factory. Okay, so you could ingest your data here from Synapse as well. Okay, and you
And
can
for the
monitor.
audience, so for the audience, the pipeline is a way to take data from point A to point B, and it could be
Correct.
on either way, and you can transform that data in the way that you need it.
Correct. It's a famous ETL ELT process that
Exactly.
everybody loves to jargon about. So, and we have this also other buttons, which is for manage and to monitor. Now let's go straight to the point of develop. Develop is where you're going to play with your scripts. Let's clean a little bit here. I'm going to clean here. So I have already created for this demo. I create in advance these queries. Okay, it's a common SQL T-SQL language. Okay, so how this work with open row set? That's a function that I'm going to query straightforward the data in any URL that I put here in blob or data lake. So let's do that. I'm going to go here. I'm going to go to my blob. Okay, here's my blob. I'm going to go into my container and I'm going to work with this guy here. Okay, this is the URL. Okay, this is the data. It's a CSV. Okay, I'm going to click the URL and I'm going to select here this. I'm going to paste this. Boom. And then I'm going to select and run the query
So you're actually querying directly
into data lake.
against a
My blob, sorry.
CSV file that is on the
Correct.
blog.
Correct.
So I definitely, you just gave me an idea. So are we saying that then a customer or someone that may have all data, or they may be keeping data because they say, well, if I need to at some point query it, I need to keep it inside the database. Now with this, they can export the data and save it in a cheaper, I'm going to call it medium, and still have the capability to query it when they need it.
I would say it's more than cheap. It's way cheaper. So if you're using your SQL to store your data and once in a lifetime you're doing an analytical process, the way to do it, what I would recommend is to do it this way. So put your data in a data lake and do this query on demand. Now, to put it in perspective, this query on demand is really, really fast. Now, this is a really small CSV, okay? But this is really fast because it's serverless. So automatically allocate computing power related to the query that I'm doing. And also between you and I is really cheap. So 1 terabyte of data is somewhere around $5. So that's why I really love to do demos about this because it's really cheap. So basically that's the idea. As you said, if you're doing analytical processes, this is the road to follow. It's not for transactional scenarios. Transactional scenarios is our own SQL. Remember that Synapse is for data analytics. Okay.
I
Now let's
remember a long time ago that you needed to build all of this type of solutions at a previous role. I remember you needed to, in order to do this query, you had to have an object store. You needed to have a tool that could do ETL. Then you needed to have a Spark cluster or a data lake cluster so you can actually be able to drop the data to do this. You just, this query took less than 5 seconds.
correct. And there's more about this because remember that we are going the road of serverless query. You can also create your data lake. Okay. So sorry, your SQL pool, which is being really honest, your old SQL data warehouse. So you create SQL pools, and with this, you create here. And once you start creating, you create the schemas and everything related for a specific computing power. Okay, so we have that option as well. But I love the part of serverless because most of the time, unless you are kind of a big company, a SQL pool, perhaps it's an overkill. Okay, so I would go first explore the option with data lake. Now, this is the other thing that I would like to show to you, which is in my link services. Okay, I have linked one Azure Data Lake and my Synapse space that I showed you in the beginning. Okay, and the file system. And the file system, I have a lot of folders. And for example, uh, I'm going to go this road, genomic data. Okay, so I go inside. I have this CSV. Click here, and I have automatically deployed the query and the information here, straightforward into the file, which is inside my data lake. Okay, you could also go different roads. Let's say that you want to explore this with your Python schemas using Spark. You can do this. You create a Spark pool, you select the language because it's multi-language, and there you go. You start querying using Spark as well here in Synapse. Why would you need to do this? It's very interesting because remember, with this information, you could go the road for machine learning. And we have a special connection to do Synapse with machine learning as well. In case that you, for example, you need high analytics or AI scenarios, Synapse is a right tool for that. You see, my friend, that's why I love Synapse.
This is a let me bring us back here so we can be in the middle. Um, this is really interesting, German, because before we used to have to build all the solutions when we were on premises. So all the solutions originally you were able to do it, but only the big companies that have a lot of money could enjoy the capability to manage their data in a better way. What I'm seeing now is that I can then, with the power of the cloud, I can decide, okay, where can I truly store my data? First of all, do I need to keep on the database? Probably the answer may be no. I may need to probably take some of the data that I haven't used, export it, and save a copy so I can use it. And number one, shrink my database. That will save me money and will make my connection faster. But now that opens other areas because, like you just show, I can leverage Synapse or Jupyter notebooks to analyze that data that could be stored in the information and get insights that should be the reason for storing data. I think
Correct.
that a lot of times, I don't know if this being your case, but I see people just using, and that's what the title, using the database as a trash can. They dump anything and everything that they can find and say, in case that I need it, I will store it there.
Correct. In that case, I would put it in a data lake instead of a
Yeah.
SQL.
So thinking about that, Synapse is available right now. It's not preview, so it's something that could start using. So I'm gonna go back into my account now that I understand a little bit better, and I will start looking because there may be different architectures that probably could be built to leverage that. But in your experience, Blob or SQL, like should they? If they don't know, where can they start? Should they just output everything and dump it into CSVs and put on the blob? Uh, what would be the probably the path for someone that is starting?
Okay. The first step would be identify what is the real data that I'm using. That's the first step. What's my critical data? Second, once I define the data that I'm now using it, move it to a data lake, for example, and leverage the folder issues to have it tidy up your data. Instead of flat, just use the folders. Then you have several options to store your data there. Remember that you have also the other format, which is Parquet, and data in Parquet. is kind of very interesting because remember that it has a compression. So if you have larger files, you could, and if you save it as CSV, let's say it's going to be 1 gig, but if you save it as Parquet, could be way less. Sometimes it's half the size or more because
Oh,
the way that it is structured. So let's say that would be the first step: identify the data and then put it as CSV or Parquet in data lake for further analysis if required.
that's actually very interesting because shrinking the data from a gig to probably half or even less, sometimes it may be the way to go. But you just mentioned something. If it's encrypted, when you're going to analyze it, it needs to be decrypted. So that could make the process slower. So sometimes shrinking it too much may not be the answer, correct? Probably
But
sometimes you may need to then, if it's for historical purposes, you may want to shrink it because you're not going to use it all the time.
well, that's a characteristic of Parquet. Parquet is kind of the lingua franca in big data analytics because it was created Parquet to compress the data, but you will not lose performance when you're querying that data. So it's really interesting Parquet.
Okay, so I have some reading to do this weekend to get up to speed on that. Um, Herman, has been awesome to have you with us today. Database or trash can? At the end of the day,
It
any
depends.
last word? It depends. Don't use it as a trash can. Use it as a trash can. Dump it wherever you want. But I think that the key is take the time to analyze your data. Take the
Optimize.
time to understand what you have. Is your database just transactional? You're gonna keep it on SQL. But if your data is files, folders, images, videos, CAD drawings, there may be time to probably re-architect your solution because that is one of the beauties of the cloud. You can actually re-architect your solution that you may end up the images go out to a blob and then just grab it from there. Same thing as the video files. So you don't have, I can't imagine a video playing from inside a database that doesn't do video encoding. That video gonna play slow as molasses. Like there's video services to do specifically that. Azure have services for transcoding that.
Correct.
So it was awesome to have you with us today, my friends. Herman, we'll see you on another call. And to our audience, thank you very much for tuning in. And we'll see you on another episode. Thank you, my friends.
Bye bye.